Good afternoon, everybody. So, as our chairman mentioned, I'm going to talk about the climate change challenge in terms of the science and also of regulations that we have to meet the targets, local, UK and European. We are going to see some of the funding that's currently available to help us meet the targets, mainly on energy efficiency and renewables. And we are going to look into some design solutions of adapting to climate change, the buildings to climate change. Okay, so let's go into some of the climate change science. This graph shows us the temperature rise globally for the next, towards the end of this century, for 3 emission scenarios. The 3 emission scenarios represent the green line, a green future, and the red line, a business as usual kind of scenario, socio-economic scenario. What is very important to realize from this graph is that until about the middle of the century, we don't have a choice but to adapt to some level of climate change. So the challenge is double. It's mitigate our carbon emissions but also adapt to the climate change that we have committed so far. And climate change is not only unavoidable, but it's also long-lasting. So we see that even if we start reducing our carbon emissions by the middle of the century, the effects that the concentrated carbon already in the atmosphere is going to cause long-lasting effects to our ecosystem, such as sea level rise and temperature rise. It was last summer that the new climate change projections were published, and they are available for everybody for free. These projections this time were presented in a probabilistic way, which means that instead of having a single number that represents a change in the future and also for each variable and emission scenario, you have a range of change from the minimum to the maximum. For example, in here we can see that under the high emission scenario for the 2050s, that we see an extreme of a change of 6 to 7 degrees. The projections are also give a comparison between current climate and future climate. On the top level, we see current climate and return periods of hot events. In this case, hot event is number of days above 28 degrees. And down we see towards the end of our century projections of hot days. And what is interesting from this slide is that what we consider now to be a 1 in 10 years event is going to be a normal summer towards the end of our century if we continue as we are. The projections also give us data about rainfall. This is the winter precipitation, which shows increase for the future, with extreme trend again showing increases of as high as 30 or 40%, and also reduction of precipitation during the summer months. The extreme this time is on the far right, your left. So we see reductions for up to 40% for the south of the UK. These graphs were produced by hand, which show, this is based on observed data, and it shows the reduction of heating degree days, so amount of heating that we've been using for the last 4 to 5 years in the different regions of the UK. And there is a equivalent for the cooling, which shows an increase of cooling demand for the same regions and the same time period. I'm going to talk a little bit about the regulations, mainly to make the point of the challenge that we have to face, the double challenge. The regulations mainly address the mitigation of climate change, which is basically our carbon reductions. And this is the range of different regulations that we have to comply when we're designing our buildings. Quickly, I'm going to go through some of them. The European Energy Performance of Buildings Directive requires member states, European member states, to improve energy efficiency, to produce energy performance certificates for everything that is, all the buildings that they are rented, built and sold. And especially for the UK, we have the display energy certificates, that they are actually showing the energy, the actual energy that the building is using. Something else that is also part of the directive is that all buildings with an air conditioning of a certain size will need to be inspected and reported. And we run a campaign at CIBSE, the no compliance costs, which is basically addressing the fact that we are not getting the numbers that we need. So far, we have 5% only of the air conditioning inspections that they should have been inspected and complied. So if you want to know a bit more, we are just around the corner in the CIBSE stand. Please come and join the campaign and find out more. So we have also the Climate Change Act, which I think Ant mentioned, the 80% reduction by 2050 with an interim target of 34% by 2020. The Energy Act also complements the climate change and gives incentives of meeting the targets by incorporating renewables and low carbon technologies in the buildings. The new Partel building regulations, we're going to see increasing the, I'm not sure why that's happening, increasing the expected improvements up to 25% for the, I think they're going to be out in October. That's going to be even more increased by 2013, up to 45%, and then even more for the 2016 regulations. This is currently the understanding of how to achieve the zero carbon goal. The pyramid shows that. Thank you. Sorry. So the pyramid shows us that all buildings will need to address efficiency first in terms of fabric. So in terms of insulation, heat, solar gains, and the building fabric. And then we go into energy efficiency of the systems, renewables, and finally allowable solutions that could be improvements of surrounding buildings or off-site generation, energy generation. I have added at the bottom that there is still some argument about how what zero carbon really means, and I guess Ant highlighted the whole issue of the embodied energy of the materials. But still, we need to achieve the targets that we have. So, so this is as far, I think, as we are at the moment. This is something else that I thought it's important to understand. It was produced by Lawrence Aston, and it shows that there is a cost obviously associated with solutions, but there are solutions that they have a high impact and low cost, and I think those are the ones that we should be aiming first before we consider the other solutions. I'm going to talk quickly about what is there in terms of help with initial costs. We have the Enhanced Capital Allowance Scheme, which is a government scheme that offers businesses capital investment in order to incorporate low carbon, efficient low carbon technologies and plant and machinery. The two main schemes that are more relevant to building services industry are the energy saving plant machinery and the water conservation plant machinery. And the plants that they are under these schemes are the ones. There are a variety of other grants and loans, such as the Low Carbon Buildings Programme, the Bioenergy Capital Grant Scheme, Microgeneration Strategy, Energy Act, and carbon trading schemes. I have a slide for each one of those. There is a two-phase in the Low Carbon Buildings Programme. The first one is for householders, community organizations, and non-profit sector groups in order to incorporate photovoltaics, solar thermal hot water and bioenergy, and phase two goes into public sector buildings, schools and hospitals, local authorities and so on, to install microgeneration technology. Another scheme is the Bioenergy Capital Grants, which are mainly focusing on promoting biomass for energy and heat generation. It's currently aimed mainly for businesses, organizations, charities, commercial, industry and community sectors, and the technologies that they are most kind of promoted by this scheme is the biomass heat boilers and the CHPs. Microgeneration strategy, that's more to do with, it's again a government strategy, and it allows the trading of energy from companies that actually produce energy, well, up to 50 kilowatts. Another energy trading scheme is the Energy Act, which is introducing the feed-in tariffs for small-scale generators. So excess energy could be fed back into the grid and be used, or the companies can use the energy that they produce. Well, that was the energy trading, and we also have the carbon trading. That's the EU scheme, emissions trading scheme, and we also have our own UK-based, which is the energy efficiency scheme, CRC energy efficiency scheme, which is similar to EU emissions, but there is a certain level of credits that you can buy by the government that relate to your carbon emissions, and then if you do well and you have extras, you can actually trade your credits, or you can buy extra if you need to. And of course, there is a lot there. There is a lot of regulations. There is high targets. a lot of technologies, but there is some expert help. We have the CIBSE low carbon consultants that they are trained specifically to address the issues, find the best technologies in the best cost for the specific projects. Mainly, our current regulations focus on, as I mentioned before, on mitigating carbon emissions and mitigating climate change. But as we saw in the first kind of slides, we also need to adapt to climate change. And air conditioning is, of course, to achieve comfort levels is not perhaps the best way to go about it. So we can see that there is a conflict there to achieve our performance and our target emissions, but at the same time providing the environment that we need for occupants. The main impacts of climate change, the better understood ones, are the overheating and heat stress because of the higher temperatures projected for the future. Also flood risk because of increased rainfall, especially in the winter, but as recently we discovered, especially in Oxford, I live in Oxford, and we flooded 2007 severely. And at the same time, water resources are scarce during certain summers that they are very, very dry. I have tried to put together certain solutions for adapting buildings to the different impacts of climate change, and I tried to list them from no-cost to high-cost solutions, starting from a very simple reducing our internal gains by switching off what we don't need, also putting solar shading in our windows, increase biomass either in new or existing buildings where possible to make use of the nighttime ventilation where possible, the use of green roofs and walls, also increase ventilation either by right design of windows or even mechanically aided ventilation. And finally, where we need to introduce cooling systems, then introduce the most efficient systems. Similarly, for managing flood risks, the first few solutions focus on minimizing inputs, entry points of water, going further into more extreme solutions such as raised floor levels, electrical fittings, equipment when there is a severe risk of flooding. Green roofs also, it's a very good management of the overflow that the drainage systems might have, and also making the drains bigger, incorporate sustainable urban drainage systems, and so on. And finally, in the management of water resources is incorporate water efficient fixtures, fittings, like low flow shower heads and low flush toilets. Use the rainwater in order to water our gardens and clean our cars. Water efficient appliances, and finally, again, I added the SATs, which is something that is quite relevant at the moment. These are some of the publications that talk a little bit more about what I just told you: water management techniques, comfort. What is comfort? What are the criteria that we are designing at the moment, and also some cooling systems that they are sustainable cooling systems. We have some of these publications in the stand if you want to flick through them and have a look. Also, there are some free publications available and resources that explain a lot the adaptation solutions that I briefly mentioned. Also, cost attached to them, what is best for your home or for a new design projects, and those two are quite useful really. One is a checklist where you go through a checklist to see if you have integrated all the current knowledge into your new development, and it gives you the case study companion gives you actual case studies that show you implementation cost and information of each of the solutions that they exist at the moment in adapting to climate change. Another free resource is the CIBSE Design Compass, which is a map really that relates the design issues when you're designing for heating, cooling, ventilation, lighting, public health and electrical systems to what weather data we have at the moment. So when you design, for example, your cooling system, you go through a 3-level framework that directs you to information of where you can find the most up-to-date information in terms of guidance and in terms of weather data, climate change data, even current research if you want to learn more. And this is just to summarize. Climate change challenge, we need to mitigate climate change by complying with our legislation, current targets, but also we need to adapt. There is current grants and loans available. There are experts to help you, and if you want to know more, just ask me anything you want in terms of climate change.